Hey, how are you doing? This is our third and final part for the differentiation review for this week. So today we're going to go through the last topic, applications of our derivatives. Our previous topics are all the fundamentals and rules that you need to be able to apply, and important parts as like implicit differentiation and parametric equations. So make sure that you've watched these before and that you understand the concepts. Let's go and have a look at our applications. So what is the whole point of doing derivatives? The most important part is critical points. And you have to remember all of these synonyms, on this side, all the other keywords that mean the same thing as critical points. Stationary points, critical points, turning points, and extreme points all mean the same thing, basically. Now, some of those can be minimums, maximums, and points of inflection. So let's have a look at some pictures. Now, all of these show us the possible ways critical points can have, the nature they can be. The first picture is of a minimum. The second one over here is the maximum, and at the bottom we have a point of inflection. Now, minimums and maximums seem to be somewhat easily understood. For points of inflections, it looks like it's kind of like half of a, minimum or maximum, and then the other part. Actually, at a point of inflection, the concavity changes from concave up to down or the other way around, but more about that later. For now, the most important part is that if you see any of those keywords, critical points, turning points, minimum, maximum, extreme point, point of inflection, any of those, you need to immediately remember the gradient is zero. And we can see that in those three pictures because I've added the tangent line at those points, at those extreme points. All of them are a horizontal line which shows us a gradient of zero. So as soon as you see any of those words in any of your questions, you need to immediately take the derivative and set it equal to zero because the gradient is zero at those points. So first step, derivative equals zero, then solve for your x values, and then substitute the x values back into the original equation to find our points. Remember, every time we want points, we want both x and y values. Let's have a look at an example. Here we've been given the function x cubed minus 3x squared plus 4. Well, the first step is to take the derivative. So the derivative, you should know by now, is 3x squared minus 6x. Now, as soon as we see these keywords, you need to remember this will help you get yourself started in these questions. Derivative equals 0. So we're going to write the derivative equals 0 and solve. Now you can solve from here using a calculator, or you can factorize to get the answer. Either way works fine. Now, once we have our x values, these are the x values of possible points for critical points. So what do we still need? Well, we need the y values. So we need to substitute both of those x values back into our original equation to find the y values. At the end, you should leave your coordinates in the form brackets x comma y for the reader as your final answer. So what do you think these are? Are those minimums, maximums, or what are they? Well, let's have a look. First, please pause the video. Make sure you're confident in finding those critical points. Both the x value, the y value, setting the gradient equal to 0 are the key concepts here. And we will do this over and over in the next few examples as well, because we're going to need those critical points to continue. So, in the last slide, I told you that we have two of the solutions, 2 points that we've been given. So, I asked you, what are they? Minimum or maximum? Well, we actually need to figure that out. And this is what we call the nature of the critical points. We have already seen that critical points can be minimums, maximums, or points of inflection. So how do we know which one it is? Well, you've got two options. You can do testing. We want to test what happens close to our critical points. This is not my preferred method, but if you like doing this, that's perfectly fine, and you can use this for full marks in the exam. I like the second derivative test because you have to know the second derivative test anyway for concavity. So I recommend using the second derivative test. Let's have a look first about the testing method. Well, here I've drawn a parabola which obviously has a critical point where the gradient is 0 at the vertex at x equals 1. But now if we look at x equals 1, we can substitute x is 1 into the equation to get our y value, which is 0. So at our critical point, the y value is 0. Now, if what we want to do is we want to go a little step before and a little step after our critical point, and we want to evaluate what the function gives us. So let's take 0.5 and 1.5 as an example. At 0.5, if I substitute this into the equation, because this is a parabola, we're probably going to get 0.25, which is 0.5 squared. Now for our 1.5, because of the symmetry of our parabola, we will also get this value. Now this might not be the exact values depending on the equation of this parabola and the scaling, but just so you have an idea about numbers, the first part, x1, gives us a positive value. The second one gives us 0, and the third one gives us a positive value. So we can kind of just make a quick sketch to figure out if we have a minimum or maximum. So let's have a look. We had a value, let's say 0.25, when our x value is 0.5. Maybe we'll do a quick table. So we've got our x value, our y values. When x is 0.5, we had 0.25, and when it was 1.5, we had 0.25 as well. But in the middle, we had when x is 1, we had 0. So how would this look? Well, at our critical point, we had 0. Before and after, we are higher, so this can only be a minimum if we connect these, or if we think about how this works. The same way, you could identify a maximum. If we have a different table of values, where our stationary point or your critical point is here, and just before we have values that are higher, and just afterwards we've got values that are lower, then we will have a critical point that is a point of inflection. If you first have something that is less than your critical point, and after the critical point it's again less, then we know we will have a maximum. Now this is the testing method. Let's go and have a look what the second derivative test is all about. So the second derivative test is telling us that we use the second derivative. So let's have a look here. We have f of x is x to the power of 3 minus 3x squared plus 4. And we've already figured out that at x is 0 and x is 2, we have critical points. That was from the example before. Now, if this was a new example, you would have to start again from scratch, do the derivative, set equal to 0, solve for x to get these values, which is why I gave you so many examples to practice on, because this will help you get the higher marks on these exams. Using the second derivative test is always going to be one part of the questions. Now we're going to list our equation f of x, f prime of x, and the second derivative f double prime of x. And remember, you just take the f prime of x and take the derivative again to find the second derivative. Now once we have these, we just substitute in our x values into the second derivative to test for values that will tell us if it's a minimum or maximum. So let's do that. We had our values 0 and 2, so let's plug them into our f double prime. If we substitute them in, we're going to get -6 when x is 0. So we have a local maximum, and we have 6 when x is 2, which is a local minimum. Well, hold on. How did I make this conclusion what they are? Well, in order to make that conclusion, we need to know exactly how the second derivative test works. So if we substitute in our x value for the critical point into our second derivative, and it's negative, it's less than 0, then it's a maximum. If it's greater than 0, so it's a positive number, then we have a minimum. And if it's actually 0, the test is officially inconclusive. So be sure that you don't mix these two up. Less than 0 makes a maximum. Greater than 0 makes a minimum. So they're kind of opposites of each other. This will not be in your formula sheet. Now, how do we find points of inflection? Point of inflections are not maximums, they're not minimums, so they would only come up if we have the second derivative is 0. But this is where our test is inconclusive. If you're ever asked to find a point of inflection, you need to compute the second derivative, set it equal to 0 to find points where you could possibly have a point of inflection. This could also happen at a point where it's undefined, but at this level, all your functions are going to be well defined, so this is not going to be an issue. If you are ever asked to find a point of inflection or to work with a point of inflection in this exam, you can just remember set it equal to 0 in the second derivative test. Be aware that this will not actually be accurate, but it will work in the sake of your exam because you have not studied further enough to be able to learn properly on what to do next and for which functions we have a well-defined critical point. Now, the last point is concavity. So we want to know the sentence that I've got here. Concave up is like a cup. So please don't ever forget this so you know what your function looks like. It's a very easy mark lost if you forget which way is concave up and down. Concave down is like a frown. So if you forgot, I'm going to look like this. Yeah? Awesome. Now, try these examples. I've given you easy questions, yeah? Easy derivatives, so that you can try and figure out critical points, second derivative test, substitute in when is this function concave up, when is it concave down, and so on. Yeah? Make sure you pause the video now, go through these. There's a lot of mistakes that you can make on the way. So be sure to figure these out, and these are your solutions. Awesome. This concludes all of our concepts that you need to know. If you're still struggling in the differentiation paper with past papers, then this is mostly a problem with the algebra. All of the concepts that you need to know to get a decent grade are covered in this little review. So, if you have any further questions, make sure you put your question down in the comments. I will answer them basically on the same day. So make sure you get your practice in. Go through the examples that I've actually given you to make sure you know what to do in the exam. All right, time for some past exam papers. So I will see you in the next video. Bye-bye.